Okay, maximum vacation days. Let's get started. So LeetCode wants to give one of its best employees the option to travel among N cities to collect algorithm problems. Wow, that's a very nice company. I love to work for LeetCode. But all work and no play makes Jack a dull boy. You could take vacations in some particular cities and weeks. Your job is to schedule this traveling to maximize the number of vacation days you could take. But there are certain rules and restrictions you need to follow. Rules are restrictions. You can only travel among n cities, represented by indices from 0 to n-1. Initially, you're in the city index 0 on Monday. The cities are connected by flights. The flights are represented as an n times n matrix, not necessarily symmetrical. Okay, called flights representing the airline status from the city I to the city J. If there's no flight from the city I to city J, this will be 0. Otherwise, this element will be 1. Also, flights equal to 0 for all I, which makes sense because you can't fly from Hong Kong to Hong Kong, right? Which does make sense. You totally have k weeks, so each week has 7 days to travel. You can only take flights at most once per day and could only take flights on which each week, excuse me. Where was I? Okay, so you totally have k weeks. Each week had 7 days to travel. You can only take flights at most once per day and could only take flights on each week's Monday morning. Since flight time is so short, we don't consider the impact of flight time. So for each city, you can only have restricted vacation days in different weeks. Given a n times k matrix called days represented this relationship. For the value of days ij, it represents the maximum days you can take vacation in city I in the city j. Now, you're given the flights matrix and the days matrix, and you need to output the maximum vacation days you could take during k weeks. Okay, so let's take a look at these examples. So flights, we have this matrix, and for days we have this one, and the output is 12. Explanation: 6 plus 3 plus 3 is 12. Okay, so from city 0 to city 1 on Monday. So city 0, 1. So 0, 1, which is 1 here. So which means, yes, there is a flight from city 0 to 1. And 6 days and work 1 day. So 6 days, 6 days and 1 day. So this is the first week, and city 1, so which is 6. Okay. Although you can start at city 0, we could also fly 2 and start at other cities since it is Monday. And the second week is we're going to fly from city 1 to city 2 on Monday and play 3 days and work 4 days. Third week is going to be stay at city 2 and play 3 days and work 4 days. That's now. Another example is if we have all zeros, it's going to be 1 plus 1 plus 1 plus 3, which means, well, there is no flight coming out of the city, and you can only you can only stay here according to the schedule of this current city. Wow, that's sad. That's pure sadness. Okay, the third example is this, which means n 7 plus 7. So this is a perfect schedule, right? You don't have to work a day, right? Start at 0, play 7 days, play 7 days, 7 days. All right. So, okay, here are the notes. Holy cow, this question is freaking long. Anyways, n and k are positive integers, and which are in the range of 1 to 100, and flights we have this range, and days we have this range, and you could stay at the city beyond the number of vacation days, but you should work on extra days that won't be counted as vacation days. If you fly from the city A to the B and take the vacation day on that day, okay, in that week, we don't consider the impact of flight hours towards the calculation. Okay. So, well, right now, if we want to do it in a very brutal way, it's a brute force way, I think we can list every single, we can have n times, well, actually it's n to the power of k time complexity. The time complexity is equal to n to the power of k. Why? Because we have k weeks, and then so we have k weeks, right? So we have k weeks, and then for each week we are going to brute force every single solution, every single city, to figure out the best way. So right now I can't think of other solutions. So if we would do this in a brute force way, it would, why am I typing Chinese? So private, let's get started. So we could do a depth search to, so we're gonna use a function to call this recursively so that we can list all the possibilities in the past k weeks. Okay, here. Now let's get started. Private int max is, say, 0, and then what we need to do is, okay, we are going to call this, let's say, a helper function. So first of all, we're going to pass the array, and then we're going to pass the days, and then what we need to do is we also need to keep track of the current week. Actually, you know what? Days, and then we keep track of the current weeks, and then we need to keep track of the current city. And other thing we need is, so we have the city and the current week, and now we need to have the total number of the current vacation days we have taken. So right now it's also 0, and we are going to return max. Okay, so, and for this problem, for this method, we are going to have void and a helper. Okay, right? So int, so these are pretty much the same. Flights, days, this is what we have, and then at the same time we need week and city and vacations. Okay, so now first of all we need to, usually the first step of a depth search method is we need to have a terminating statement. So now, first, if week is equal to, so now the days is represented as city I in week J, city I in week J. So the number of columns of the days matrix is how many weeks we have. So days 0 dot length. Okay, so if week is equal to this, and then it's time for us to tap out. So if week is equals to this, so max will be equal to math.max, and between this vacation and max, and then we'll return. So after that, we're gonna brute force I is equal to 0, I is less than n, and I plus plus. Okay, so now what we need to do is first we need to determine if it's a valid trip. So what I mean by that is, so first of all, let's check. Okay, if the current city is equal to itself. So if we don't fly, if we stay in our city or flights from the city to I is valid, right? From the city,
Okay.
I don't know, city. I think my iPad is mistakenly for the mistaken city as Siri. City. Okay. All right. So if this is equal to 1, all right, what do we do? Now we're going to do helper, same thing, flights, days, and the week is still this week. And then we are going to have city and I, and then we are going to do the current vacation plus days. So we have this week and I passed my 15 minutes mark. Damn it. What the? Sorry. Okay, 15 minutes has passed. Oh, almost. Okay, so now days and we need a city. So city is I, right? So city I and the current week. Okay. So helper current week plus the city, the number of days that we can take vacation in this city. Okay. And this week. Okay, perfect. All right. So let me see. Oh, and yeah. Shit. Missing an N here. So N is gonna be a number of cities that we have. So it's gonna be flights dot length. Oops. England is my city. So I think it should be week plus 1 instead of week. Let me try. Okay, 12, yeah. Sorry, it should be week plus 1 because we are advancing to the next week. Because of this, right? Week is equal to this, so we should, yeah. Okay. Anyways, stupid mistake. Anyways, so we have 12 and 12. Now let's see if we can pass it. Time limit exceeded. Okay. So we obviously have a hard time passing it with the big data. Okay, so we need to figure out a faster way. So now can we do dynamic programming? Can we, instead of brute forcing it anyway, can we try to optimize the best day, the maximum vacation days that we can take for each week? So at the end of the day, what we care about is the current city, the maximum days that we can take with the current city compared to the previous city that we took vacation at. Okay, so it's going to be n. Okay, let's try this. N is equal to flights dot length, and then so this number is city, and n k is the weeks that we can, how many weeks that we can take vacation of, days. So this is I week, right? Days is days days in week. So how many weeks? If you want to determine how many weeks I have, it's the same thing as this one. And then we need to have a array to keep track of the maximum days. And then, but since what we care about is, so here, since what we care about is the maximum day, the total of the maximum days in the last week. So we don't need to keep track of every single week. We just need to keep track of the week that we just been through. So this is gonna be how many cities we have. English names by city. Now, so it's gonna be 4 and hold up. So first of all, we need to initialize this array so that we can do comparison later. Arrays fill dp. It's gonna be integer min value. Okay, and after that, one more thing. Since we start from the city 0, so there's one thing that we can be sure of is that the first week at the first city, the maximum days we can take is 0. So dp 0 is equal to 0. And then, okay, so let's get started. I equal to actually, so we're gonna have how many weeks we have? K is equal to 0 and K less than K, and then K plus plus. Okay, so and then we need a temporary we need a temporary array to keep track of the current maximum numbers that we are having. So int, so it's basically the same as the dynamic programming array. It's gonna be, let's go temp, it's new int, and then at this also we need to initialize this. Okay, and for I is equal to 0, I is less than n, I plus plus, and for I, j is equal to 0, j less than n, j plus plus. So now, you know what? For good habits, I'll still, okay, so for every city, we need to make sure that we have the most optimal, well, first of all, we need to make sure it's valid. So if I is equal to j, so if it's the city itself, or flight from j to I is valid, then what we need to do is so for this current city, we're gonna get is it math? Okay, math. Okay, so we're gonna compare the current maximum day or the maximum day of the other city plus days something is wrong. How should I? Okay, I'm confused here. So let me see. So we need to make sure that okay, so the maximum day of the current city will compare to the maximum days the dp of the other city plus this is week I need some coffee. Week city I week J. So in this case it's gonna be week K and city I. Right? DPJ plus date stays to current state. So we're comparing the current. We're comparing. Okay, we're comparing which city, the optimal result of the previous city plus the current vacation days. We're comparing among across all these cities, right? We're comparing the vacation days of the current stop plus all the previous stops. All right, so now, and after that, we will assign temp to DP. So temporary is like the current. Temporary is like the current week, and TP is like the previous week. Okay, I guess I don't have much time left. 2 minutes. Stupid. Okay, so we only have 2 minutes left. All right, so after that, for every single day in DP, we have max is equal to 0, and for max is equal to max day and max. Okay, and then return max. Okay. So since we only have less than 2 minutes left, we'll just run it, compile it directly without eyeballing the code. Is it flights? Okay. Max. 12. Okay, looks perfect. Okay, let me submit it. Okay, it's ready. Let me see. Accepted! Yay! Okay, so yep, dynamic programming worked, and then I think the point of this, yep, so the point of discussion is we are going to compare so we are adding So we are adding the optimal result of the previous week with the current city. All right, time's up. Shut up. Anyways, thanks for watching and happy coding. I'll see you next time. Bye bye.